Assalamualaikum and good day everyone. Today we are going to continue with lecture 2 of polynomial, which is we are going to focus on 6.2 remainder theorem, factor theorem and zeros of polynomial. So for today we are going to apply the remainder theorem to solve the problem. So all of you must have to know and understand what is remainder theorem. Okay. What is the remainder when polynomial px equal to 2x cubed minus x squared plus 3x plus 1 is divided by x minus 2? So we will use the long division to get the remainder, right? So we have 2x cubed minus x squared plus 3x plus 1 divided by x minus 2. So this x minus 2 will be divisor. So to get the quotient here, we have to multiply with 2x squared. So we have 2x squared and then multiply the 2x squared with all the terms in the divisor. So we have 2x squared minus 4x squared. 2x cubed minus 4x squared. So subtract everything, we get 0 and negative x squared minus negative 4x squared will be 3x squared. So bring down the 3x, so plus 3x. So to get 3x squared, we have to multiply x with 3x. So positive 3x multiplied by x minus 2 will be 3x squared minus 6x. So find the remainder here. We get 0 and then 3x minus negative 6x will be 3x plus 6x, which is equal to 9x. So bring down the 1. So we have 9x. So to get 9x from x, we have to multiply by positive 9. So positive 9 multiplied with x minus 2, we get 9x minus 18. So subtract these terms, these two expressions, 9x plus 1 minus 9x minus 18. So we get 1 plus 18, which is equal to 19. So the remainder for this px divided by x minus 2 is equal to 19. So what is the remainder theorem? So if we substitute x equal to 2 in the above polynomial, why x equal to 2? Okay, so we have a divisor equal to x minus 2, right? So we let x minus 2 here equal to 0. So the x is equal to 2. So if we substitute this x equal to 2 into the polynomial px, what we obtain is actually equal to 19. So 2 of 2 cubed minus 2 squared plus 3 of 2 plus 1 is equal to 19, which is the remainder. Right? The same value we have if we do the long division and we get the remainder here equal to 19. So, what can we say about the experience previous experience? We do the long division and we get the remainder. So it's actually talking about the remainder theorem. Okay, so when a polynomial is divided by a linear factor, so we have linear factor x minus a. Okay, so we have x minus a. This is a linear with x to the power of 1, right? So the remainder is actually we substitute this value a into the polynomial. So we can find the remainder by just substituting the value of a into the polynomial. Okay, so px equal to dx plus qx plus rx. When dx equal to x minus a, we will substitute the x minus a into the divisor here. Okay, so what do we have? What we have later is actually the PA is equal to RA. Can you understand? It's actually the remainder. Okay, where we substitute, let's say we have the RA from the previous one is RX is equal to 19. So RA also equal to 19. Why? Because we don't have X, so we don't have to substitute any value. Okay, the RA means that the R of 2. So P of 2 we also get 19. Right? So P2 is equal to R2. So let's do some example. compute the remainder when px equal to x cubed minus 3x squared plus 6x minus 2 is divided by. So all of these are linear, right? All of these are linear. Now we just have to find what is the value of a that we need to substitute into the x here. Okay, so the divisor is x plus 2, means that the remainder, which is equal to r of negative 2, because x plus 2 equal to 0, means that the x is equal to negative 2. So the a, this is equal to our a. Okay, so we can substitute into r equal to negative 2, which is it's actually equal to p of negative 2. So just substitute negative 2 into the polynomial we have here. Okay, so substitute negative 2, we have negative 2 cubed minus 3 of negative 2 square plus 6 of negative 2 minus 2. So what we have is negative 34. So this is the remainder. So you don't have to do the long division just to find the remainder for a linear factor. Okay, so if we do the long division, let us check together. So x cubed minus 3x squared plus 6x minus 2. So the divisor is x plus 2. So x squared, so we have x cubed plus 2x squared. Minus minus, we have minus 5x squared plus 6x. So minus 5x squared minus 10x. So we have 16x minus 2. So plus 16. So minus 16x. And then 16 plus 2 is positive 16 multiplied by 2 is 32. Go minus here. 16 minus 16 done. Negative 2 minus positive 32 is negative 34. Okay, the same value as we use the p of 2. So we don't have to do the long division just to find the remainder. Okay, it will be a wasting time for you. So what we need to do, we just use the remainder theorem to find the remainder for a linear factor as the divisor. Okay. Okay, so let us try the second example when x equal to x minus 1 is the divisor. Okay, means that the a is equal to 2, so we just have to find p1, no, the a equal to 2. Sorry, x minus 1 equal to 0, so x equal to 1. So we substitute 1 into the px. So we get 1 cubed minus 3 of 1 squared plus 6 of 1 minus 2. So we have the answer 1 minus 3 plus 6 minus 2 is 2. Okay, so you don't have to do the long division. Now for C, when 2x is the divisor, so 2x equal to 0, so x is equal to 0. So we just have to find remainder by substituting 0 into the polynomial. So we get negative 2. Okay, so it's really simple. By using this remainder theorem, you don't have to, you can skip the long division. Okay, to find the remainder for a divisor, for the linear factor of divisor. Okay, now let's continue. Okay, so for example 2, when px equal to 3x cubed plus mx minus 6 is divided by x minus 2, so this is our divisor. The remainder is 8. Compute the value of m. So we have the rx equal to 8 when we divide by x minus 2. So by using the remainder theorem, what we can say that p2 is equal to 8. Why? X minus 2 is the remainder, means that x equal to 2. So R2 is equal to P2. So we can find the remainder by substituting 2 into the polynomial. That's why P2 is equal to 8, because it is given that the remainder equal to 8. Okay. Px sama dengan 3x kuasa 3 tambah mx tolak 6. Bila dibahagikan dengan X tolak 2, dapat baki 8. Maksud dia apa? Kita boleh gunakan remainder theorem. X sama dengan 2, masuk ke dalam polinomial, dia akan dapat remainder baki yang sama. So, that's why P2 equal to 8. Okay? So, kita masukkan 2 ke dalam polinomial tu, kita dapat 3, 2 kuasa 3 tambah M darab 2 tolak 6 sama dengan 8. Okay. So, we have the value here is 8 multiplied by 3 equal to 24 minus 8 is 18 plus 2M equal to 8. Right? So, bring all the constant to the right side. We have negative 24 plus 6 plus 8. So, 14, negative 10. Right? So, 2M equal to negative 10. So, M equal to negative 5. Okay? So, just by using the remainder theorem. Okay, so you don't have to do the long division. We cannot use the long division though. We cannot find the value of M if we use the long division because it's in the polynomial. How can we find the remainder? We have remainder 8. So how do we find the M? So you cannot use long division here. So you have to use the remainder theorem. So example 3. Given that P of x equal to 2x cubed plus ax squared minus 6x plus 1, when px is divided by x plus 2, so the divisor here is x plus 2, means that if you use the remainder theorem, it's x equal to negative 2. The remainder is twice of the remainder when px is divided by x minus 1. So when x equal to 1. So compute the value of a. So they didn't give the value of remainder, but they give the ratio. Okay. Baki, dia 2 kali ganda kalau dia bahagi dengan X tambah 2. Compare dengan dia bahagi dengan X tolak 1. Maksudnya apa? Remainder P of negative 2, 2 kali ganda P of 1. Betul tak? Kalau kita baca balik ayat tu. Okay. So, we can use the remainder theorem. P of negative 2. 2 times of P of 1. Okay, so just substitute the value negative 2 and 1 into the polynomial. So we have negative by negative 2, 2 multiplied by negative 2 cubed plus a negative 2 square minus 6 multiplied by negative 2 plus 1, and 2 times of 2 multiplied by 1 cubed plus a 1 squared minus 6 1 plus 1. Okay, so what do we have on the left side? The constant we have is negative 8 multiplied by 2 is negative 16 plus 4a plus 12 plus 1. And the right side we can expand it. So we have 4 plus 2a minus 12 plus 2. So we group the a together lah. So we have 2a. Just simplify on the left side first. So negative 16 plus 12 plus 1 is negative 3. And the right side we have 2a minus 8, minus 6, sorry. Okay, so bring the a together. We have 2a equal to negative 3. So a equal to negative 3 over 2. So you cannot use long division. You have to use the remainder theorem. So example 4. The polynomial ax cubed minus 7x squared plus bx plus 8. So we can represent it as px. Leave a remainder of negative 6. So this is remainder negative 6 when it's divided by x minus 2. So when the divisor here is x minus 2, means that we can use the remainder theorem. X equal to 2 means that r of 2 equal to p of 2. And a remainder of 5. So this is the remainder. When divided, this is a divisor, x minus 1. So when x equal to 1, so p1 should be equal to r1. So to find the remainder, we know it's equal to p of 1. Compute the value of a and b. So we have two information here. When it's divided by x minus 2, So P of 2 equal to negative 6, the remainder. And then it said that when divided by x minus y, the remainder is 5. So P of 1 is equal to 5. So we have two information here. We substitute 2 into the polynomial and we substitute 1 into the polynomial. We will have two equations with two unknown a and b. So if we have two equations with two unknowns, means that we can solve the value of a and b by using the simultaneous equation. So P2 is equal to negative 6. So substitute 2 into the polynomial. It will be a2 cubed minus 7 2 square plus b2 plus 8 equal to negative 6. So simplify this expression first before you do the simultaneous equation. So what do we have here is 8a minus 28 plus 2b plus 8 minus negative 6. So group the constant on the right side together. So we have 8a plus 2b equal to 14. And then simplify, we can divide by 2. So we have 4a plus b equal to 7. So this is the first equation from P2 equal to negative 6. And then we have another information P1 equal to 5. So we substitute 1 into the polynomial. So we have a1 cubed minus 7 of 1 squared plus b of 1 plus 8 equal to 5. So simplify the same thing you do for P2 equal to negative 6. So we have a minus 7 plus b plus 8 is equal to 5. So a plus b equal to 4. So this is the second equation. So to solve these two equations by simultaneously, we can use elimination or substitution. So the easiest way here is to use the elimination. So equation 1 minus equation 2. So we get 4a minus a equal to 3a. b minus b is 0. 7 minus 4 is equal to 3. So 3a equal to 3. So a equal to 1. So we can find what is b. Substitute a equal to 1 into equation 2. We get 1 plus b equal to 4. So b is equal to 3. Okay, now we found out already what is the value of a and b. Okay, now we have another information about the remainder theorem. Okay, so when a polynomial px is divided by x minus a multiplied by x minus b. So this is multiplication between two linear factor. Means that this is actually a quadratic, right? This is originally a quadratic. So the quadratic you can factorize, means that it's multiplied between two factor. Then the remainder is mx plus n. Why? Because our divisor is quadratic, the remainder should be in the form of linear. It might get a constant, but the basic form is a linear. Because earlier, we divide with a linear factor, we should have what? A constant. So it will be 1 degree down. Okay, so let's see this explanation. So px equal to dx plus multiplied by qx plus rx, right? So if dx equal to x minus a, we have the remainder of a constant. But if we have dx, the divisor equal to x minus a, x minus b, which is a quadratic, we will have a remainder of mx plus n. So px equal to x minus a, x minus b, qx plus mx plus n. Okay, because the divisor is a quadratic, two linear factor. So you have to remember this theorem other than the remainder theorem. Okay. Let's do some example. Using the remainder theorem, find the remainder when px equal to x cubed minus 2x squared plus 3x minus 5 is divided by x squared minus 4. So, the divisor is a quadratic. Okay. So, it actually can be factorized into two linear factor, which is x minus 2 and x plus 2. So, when it's divided by 2, or when it's divided by x minus 2, we will have a remainder 1. And if it divided by negative 2, we will have x divided by x plus 2. Divisor is x plus 2. We have negative 27. Okay? But we want to find the remainder when it is divided by x squared minus 4. So, how to find this? Okay, so it's a quadratic, means that the remainder should be mx plus n, a linear form. So we use these properties, px equal to dx qx plus rx. So px is equal to x minus 2, x plus 2, qx plus mx plus n. So how to find it? Okay, so we know when x equal to 2 or a equal to 2, the remainder is 1, right? So means that the R2 also equal to 1. So P2, what is P2? We substitute into that value. 2 minus 2, 2 plus 2, and then multiply by Qx plus M2M plus N. Means that the here is R2 also. So what substitute the 2 into the Mx plus N. So what is P2? P2 is equal to 1. We know already because we find out earlier. So 2 minus 2 is 0. 2 plus 2 is 4. 0 multiplied by 4. This is 0. This is 4. This is Qx. So 0 multiplied with anything will be 0. Right? So what's remained here is 2m plus n. So this is the first equation. Another information we have is P is negative 2 equal to negative 27. This is what we found out earlier. So means that it's equal to R of negative 2. So we substitute negative 2 into the P and we get P negative 22 equal to negative 2 minus 2, negative 2 plus 2, Q negative 2 plus negative 2M plus N. We replace the X here with negative 2. And we know P of negative 2 equal to negative 27. But on the right side, negative 2 plus 2 here is equal to 0. So what's left is minus 2m plus n. So this is the second equation. So to solve for value of m and n, we just have to solve the equation simultaneously. So equation 1 minus equation 2. So 1 minus negative 27 is 28. And the right side 2m minus negative 2m is 4m. N minus n is 0. So m is equal to 7. Now we find out the m, we can find the value of n. See, this is a bit complicated, but we have to use this equation to solve for mx plus n by knowing the remainder for the divisor individually. Okay, so to find the value of n, we can substitute into equation 1. So 1 equal to 2 multiplied by 7 plus n. So n equal to negative 13. So the remainder is equal to, we haven't finished yet. So we have to substitute the value of m and n into the form of remainder of the quadratic divisor. So it will be 7x minus 13. So this is our answer. The remainder when it's divided by the quadratic x squared minus 4. It should in the form linear. Okay. So let's try another example. Example 6. When polynomial x equal to 4x cubed plus px squared plus qx plus 5 is divided by x squared minus 1, the remainder is 2x plus 3. Now we know already what is the remainder. We don't know what is p and q. Means that we have to solve for the unknowns lah. So compute the value of p and q. So by using the remainder theorem, we have x squared minus 1, which is the divisor is in the form of x minus 1, x plus 1. Okay? Okay. Now the remainder is equal to 2x plus 3. Means that Rx equal to 2x plus 3. So by using the polynomial equation, so we have px equal to x minus 1, x plus 1, qx plus with the remainder 2x plus 3. What you should do, just, yes, we just have to substitute the value of px on the left side with the right side we have here. So px kita is 4x cubed plus px squared plus qx plus 5. And the right side we have x minus 1, x plus 1, qx plus the remainder 2x plus 3. So these two is the same. This is in the normal form. This is in the remainder form. Remainder, factor and quotient form. Okay. So what we can compare is that when we substitute 1 into this equation, because 1 x equal to 1 is when the factor is x minus 1. Okay, so what we have on the left side is for 1 cubed plus p 1 squared plus q of 1 plus 5, and then the right side 1 minus 1 is multiplied by 1 plus 1 multiplied by qx plus 2x plus 3, which is x is also replaced by 1. Okay, so this part will be equal to 0, right? Why? Because 1 minus 1 is 0. So what's left is 2 multiplied by 1 plus 3, which is equal to 5. So this is 4 plus 5, which is equal to 9, p plus q. So p plus q equal to negative 4. This is the first equation. The second equation, when we substitute x equal to negative 1, because the remainder of negative 1, p of negative 1 equal to r of negative 1. So we substitute negative 1 into the px, we get 4 of 1 negative 1 cubed plus p of negative 1 squared plus q of negative 1 plus 5, and the right side it will be 2 of negative 1 plus 3. Directly r of negative 1. So we can just ignore this part actually, because it will be negative 1 plus 1 will be 0. Okay, that's why it's 0 here. Okay, so what we have on the left side is negative 4 plus p minus q plus 5. So p minus q plus 1 equal to 1. So p minus q equal to 0. So this is the second equation. So what we have here is two equations with two unknown. Equation 1 and equation 2. So to solve for p and q, we just solve it simultaneously. So what do we have? P plus q equal to negative 4, p minus q equal to 0. So 1 plus 2, why 1 plus 2? We want to solve for p first. So p plus p is 2p, q plus negative q is 0, negative 4 plus 0 is negative 4, so p equal to negative 2. Now substitute p equal to negative 2 into equation 2, so we have negative 2 minus q equal to 0, so q equal to negative 2. So both p and q are negative 2, means that the polynomial px is equal to, we can just replace the p and q lah. Okay, but the question asks you to find p and q, so you don't have to do anything, just left your answer like this. Okay, so that's all for polynomial, for remainder theorem. Okay, so next lecture we will continue with the factor theorem and the zeros of polynomial. Okay, what it means by factor theorem is actually continuation from the remainder theorem. I hope you guys understand the remainder theorem, why we need to know the remainder theorem, so how to relate the remainder theorem to find the remainder and so on. To find remainder or to find the unknowns in the polynomial. Okay, so there are some examples in this lecture that you need to understand. So the tutorial question might follows this type of questions. Okay, so that's all for this lecture. Thank you.